there everyone, how's it going? I'm Tobias, and today we're playing some more Wild True Learn. Let's hop right into it. So we finished off last time right after the next story mission. We started our own little startup, the Pizza Shack, and we did some on-the-side job. And now we have our first job involving a neural network. Let's check it out. Yeah, so I've managed to make my computer detect the cat. But that beast is a complicated soul. It definitely has more to hell. Maybe it's time to go next level and start recognizing emotions. Ever heard of perceptrons? They were invented in the 60s to recognize written text. Everyone knows that everything invented in the 60s is awesome by default. The double helix, rock'n'roll, lava lamps. Also, you can maybe switch to dogs instead of cats. Decision trees work like magic for my Pluto. You can also hit the store and get that random forest node. A forest is more effective than just one tree, you know? Okay. Now for something different. Perceptrons can actually learn and improve. Bad news, they also make a ton of errors on the way. The percentage of errors is shown at the top. Alright, so now we don't get a 100% specified outcome, only a percentage chance, but we don't have to hit a 100% mark anymore. 60% has to be accurate. Use training mode to teach in the game. In training, perceptrons reduce the amount of error while trying to predict the shape of an element. In test runs, perceptrons only predict. In the real world, Rosenblatt's perceptron used in Mark 1. This perceptron could recognize only simple linear dependencies, but it was enough to recognize English letters. What? I thought they were kidding around. First letter detection at 60s. That's actually rad. Okay. Let's definitely go ahead and slow this down. I want to see this in a bit more action. So you're right now training, and the error rate is falling. You can see there's a triangle going up here, triangle going over here. There'll probably be a circle on the wrong path at some point. Yeah, okay. So we now just let it train and the error rate is dropping. The node on the field have reached their minimum margin of error. There's nothing more you can teach them. Okay, how do I know it is minimum? Okay, it just tells me, alright. Okay, let's do a test run. And, okay, so we just had a circle enter the middle node. Therefore, it went from 100% accuracy to a bit lower, but it wasn't needed to be 100% anymore, so we're good on that front. Continue. Perceptrons, good for pictures. Grandpa probably used it. Let's go laterally first. Dairy products. Second. Okay. So this was training. And that's a task. Alright. Hello, my name's Sam. I own a dairy products factory. My dream is to make the very best goods on the market, and that's impossible without high accuracy in the fermentation process. Alright, up with the fancy words. I want a program that will judge the quality of a product by its ingredients. We often make mistakes when doing it manually, and a lot of our product never leaves the factory since we mark them as defective. We have the data. We need the algorithm. Alright, and we have 3 private emails. These are new. I didn't even come up. Okay, the history of the expert system. Okay, that's something we actually already knew. Who invented the decision tree? Data analysis method. The first ideas for creating decision tree date back to the works of Hoveland and Hunt in the 50s of the 20th century. However, the fundamental work that gave impetus to the development of the direction was a book named Hunt, Marion and Stone Experiments in Induction. Okay, and a letter from Mom and Dad. Hello, dear. We remember how you cherish your financial independence, but come on, your birthday is just around the corner. Be a good kid and take this money and buy yourself something nice. Will you? We love you very much. Do not forget to put a hat on, it's cold outside. Alright. Nearly 2 grand. Take it. Okay, should we maybe check? Is there? We could sell our pizza pack balance for 1,000. Is there anything to patch here? Not at all. Alright. Okay, now we hop into the dairy products thing. Yeah, we have to do it with a Perceptron. And I'll say we just let circles go down, everything else goes up. Let's train that thing. Okay, minimum error margin. Let's make a test run. What would we need? What does that mean? That's new. Launch complete. Oh, what the fuck? Oh, we only got bronze. What would have been needed for gold? Wow. Alright. Well, we finished it. So that's fine by me. Oh, we have to redo the test run. Fuck. Okay. Oh, there's no silver tier. And we nearly finish it in time by like half a second or so. Okay, release. Time is passing by and the market changes. When hype icon is yellow, it means that your target audience is already aware of your startup. Don't expect many new users at this point. Okay. When hype is gray, that means you satisfied your target audience. Users starting to leave. Watch your earnings carefully. When the number becomes red, it's time to cash out. Okay. So we should keep that in mind. All right, let's check Seabay. I don't want any of this optic. Hardware. Increase socket processing queue by 3. Oh, I have these two already, right. Alright, we already have everything. Let's get back to the tree. Metal Gear Construction is another task. Let's check it out. Metal Gear Construction Factory. Hello, we are the Metal Gear Construction Factory. We produce fittings and supply raw materials to construction grounds all around the world. We are especially proud of our high standard of quality. At the moment, we receive a lot of new orders and we are running late with the deadlines. An algorithm is required that will analyze the quality of raw material and discard poor quality ore before it leaves the conveyor. Manual analysis takes way too much time. Right, oh boy. Okay, we have a Perceptron. Oh. Okay, I'll feed it into the Perceptron first. And then, if it's a triangle... Oh, I don't have access to... Ah, no worries. If it's a triangle, I'll put the red ones in the trash. And the green ones might go through, and half of the blue ones will go through. Looking at it, we have more blues, so the blue ones will go through, and half of the green ones will, like, 35-ish. On the other hand, the other two shapes, a bit more tricky. I'll put the red ones through. To the bottom one red. If it's green, I'll do this. Where? No, I'm gonna do blue as well. So, here's how the system works. We sort, and we check the triangles. Red ones get discarded altogether, and blue ones get put out 100% of the time. Meaning we already hit roughly 30, or 0.8 times 30 for this. Then green, half of the green triangles land here, the other half gets destroyed. Yikes. Putting it on the other side, we have circles and squares. The red ones all go through, so we are already at 20. We already accomplished the goal. Then blue ones get destroyed, which is most of them. And then we will push around 15 off-colored in, but that's good enough for what our job entails. So let's see how good this works. Let's do a test run. I expect 70% accuracy. Okay. Oh boy, that was apparently way slower than expected. And it failed. I didn't know we could fail. Let's not work further here. Let's check another task maybe. Oh. Task with real RL. I have no idea what RL means, but we can do it. Reinforcement learning. Oh, hello. We is a society of peoples who love cats. Oh shit. We want our cats to has all the business. The best. We want cats to drive with cars no human inside. But cats have no hands, cats has paws. Yeah. Oh, what's that? In reinforcement learning, task nodes work in a bit different way. All data is initially unspecified and your task is to recognize it and transmit it to RL agent, the AI. Get the unrecognized data on the input and classify it as either an object or a road. Huh? This is Sift. Alright. So, if it's an object or a road. Test run. What would that be used for? Anyway. Oh shit, what the fuck? On this screen, you're training and testing your AI. AI acts basing on data you've been recognizing when building your scheme. The data is about the data about surroundings on the road are processed from your scheme to machine learning model. Your car won't be capable of learning and detecting obstacles without it. So there's the environment. Whatever came in, we processed and now gets stuff to Scheiße. That was German. The goal in this type of task is to make the AI clever enough to be able to reach a target average speed. Press supervised learning and drive the track yourself using WASD to teach the AI. Be careful, the car sees only objects inside a leader area. Green. Alright, so we have to drive the car. Oh, when there's an object coming up, we have to overtake. So, overtake here. Maybe go a bit faster now. Car should be able to do 60. The training and watch the cars. AI trying to reproduce your actions. We hope you've been driving safely in the supervised learning. Okay, let's see what the car is doing. Evolve. And it hit the thing. And we have achieved the speed limit. That was not good. We hit a car. Press test and enjoy result. If the result isn't good enough, try training the car again. Test run. Okay. Oh, wow. That's not at all how I drove. It's braking and all. I never did any of that. Server costs $75. UAI cost $2,500. Average speed 70 something. Yeah, release. Okay, we're getting $2,400. That's good enough for me, I would say. Let's do some. Let's get out of here. Okay, we're still in the red, so let's stick around with this. Let's do some text recognition. We are aware that you're able to create a text recognition system based on the Rosenblatt perceptron. We want to distinguish vowels from consonants. It's simpler, but we need higher accuracy. Okay. We can hit 75% accuracy just by a single perceptron. That's doable. So let's get circles up here, squares down here. Just, I don't know. Put triangles down here as well. It's not really one way or the other. Alright, and the test run. With a 20% error rate, we should hit 80% accuracy, if I'm not completely missing my math here. Only thing is the upper one will take some time, and we actually hit gold. Release. That was easy. Cat Cash Bank, Mama Smith's Pizza Shack. Reward 7,600. Cat Cloud minus 5,000. Oh, because an entire week finished, I presume. Ow. Okay, let's check the self-driving cars. That's another startup. One does not simply walk into Silicon Valley. Complete the tutorial startup Mama Smith's to gain access to the others. Shouldn't we... we could... we can sell it for $2,000. That's actually a lot of money. Anything I want on CeBay right now. These two, whatever they are. Poster and like a nice haircut. Let's sell it. Boom. Let's hop into the next startup, which is self-driving cars. Hi, we're trying to launch our self-driving taxi service. It's a very promising startup. But we have a problem. Our algorithm makes a lot of errors and it tries to recognize traffic lights. As a result, the car sometimes moves instead of stopping. Oh, that's actually terrible. And they need fast code. Alright. We're investing $4,000 and opening up the next startup. You don't need to train your nodes while working on a startup. They already have the minimum error. Okay, that's actually good. We don't have access to all our stuff at the moment. So let's do this. That's pretty simple at the moment. There's nothing here. Test run. We're hitting the accuracies we're hoping for, so release. Okay, I'm pretty excited. So at the moment we'd be making 20% loss. Let's see how it looks the next day. Parallel calculations, load balancing. That's a type of node. We present a scientific center. Our current programs are underperforming. Can you parallelize our calculations? To process data, your nodes need computing power. A server. Certain nodes require more than one server. Oh, okay. The more servers you use, the more expensive your scheme becomes. This node requires additional server power. A load balancer is a device that distributes networks or appliance traffic across a cluster of servers. Oh, I opened up Wikipedia by accident. I opened up. In the game, this node routes elements to the least overloaded socket. In the real world, a load balancer is a device that distributes network or application traffic across a cluster of servers. Load balancing improves responsiveness and increases availability of applications. Alright. Let's do this. Oh, and now we're using 2 servers. Okay, I'm starting to get it. Okay. Do test run. Epic. Pretty epic. And oh, okay. It's not always possible to satisfy all your customers in one day. Users with unfulfilled requests are shown in red. You don't have the instruments to solve this problem for this startup, but you'll get some in the future ones. Alright. Alright, I see. Sales prediction. Let's go back to basic machine learning. You've bought a stock of trees for the holidays. Friends say that you can calculate the peak demand period for them. Please help us. Oh, that's just a decision tree. Let's put green down here. No, wait. Yeah, that's not good. Wait, it is good. We definitely get all the greens down. How is that supposed to work? Any go up, green goes down. Easy as that. I forgot there's the any option. There's probably some task that could have been made very, very easy if I remembered that. Release. Right. Let's check on our startup. Still not everyone satisfied. Jesus Christ. Let's do an ancient artifact, whatever that means. G'day! Our group is working on finding an ancient artifact called Tesseract. It's a very unstable element which radiates energy in different specters. We have almost found out how to use its power to benefit humankind, but we need the smart algorithm that will separate and direct the flows of energy correctly. Revolution in energetics is just around the corner, my friend. Alright. Yeah, by the way it's laid out, I'm expected to do this. Also, I have 3 components, so I probably won't be needing... Let's put green up here. Red down here. But let's put blue down here. And red can go either way. And at the bottom, we do it similarly by saying red down here and green here. There's probably some math I could do on this. Yeah, there definitely is. But it should work out. Let's do a test run. If we hit the mark, I'm happy. Okay, we hit the mark. We're getting gold. Let's release. And we're up here. The startup is doing good. Let's do new product. Top of the morning to you from Zimoletto Outfit. We are trying to optimize our production lines and we need a system that will distribute textiles by material and send them to the respective conveyors in full amounts. We believe that you could nail this job, so we look forward to hearing back from you. Oh boy. We're getting mixed inputs here. Literally. But let's, at the bottom, let's just go ahead and split this up. Because we're getting 150 in, divided by 2, 75 each, that should be fine. And on top, We're putting 20 up here. But it takes a second each time, yeah. To parallelize this. And let... No, exactly, not squares. Triangles, which don't come. Circles up here, squares down here, and just... I don't know, put them down again. Does that work? We can't possibly hit the time frame with that. Let me edit this scheme. Let's ditch everything. How about we split this and grab the circles from both? Let's delete this. Did this again. Yeah, that looks better. So with that and that, we have a circle coming in every half second. And that should fill the demand. Right? But let's put squares here. Circles up here. That way triangles go up here as well. And this will send squares into. That should better, I hope. Oh my god, I'm backing up that system. Gold medal! What did I tell you? Oh, that was a doozy. But it did work out. Let's cash in on that gold medal. And large parallel calculations. Let's check them out. Hey, your parallelization system broke after last Doors OS upgrade. Can you fix it? Darkest Year in Machine Learning. In 1969, Seymour Papert and Marvin Lee Minsky wrote a book called Perceptrons. In this book, they spoke about mass constraints of the first perceptrons, the XOR problem. This book has shifted the scientific interest and funds distributing from the US government organization, slowing down the progression of machine learning for almost 30 years. The expanded version of the book was released in 1987, containing chapters that disproved the statement from the critical remarks made in 1969. But we just need to flip twice. That's... Why is that a task? Probably just to tell us that it's even possible, but that seemed way too simple. Anyway, let's release. And before we continue here, we have something new on Seabay. Oh, it's just a cat skin. Yeah, I do want the Viking helmet on my cat. It's undeniable. Anyway, Viking helmet. Hell yeah. Would you please rate the game? Will do after the recording. Let's do laterally at first. Secret information. Basic machine learning. Good day to you. We're a secret military organization. Yeah, that sounds legit. Our code name is Protoss. Everything you're going to read further is classified. Our analysts are sending operatives to various war zones. An escalation of conflict with the enemy has recently occurred. We are in need of a self-learning algorithm capable of sending dedicated units to respective parts of the battlefield. And we're having access to 4 of our standard tools. We need 30 up here, 60 down here. I'm thinking split it up. Half can just go down. And from what's up here, we put red here, green here, and then the other half will just go. Is that feasible? Not at all. It is. We still got gold. Why am I thinking so hard about this? Let's do Cyber Initiative. Greetings! Our company, Cyber Initiative, is into manufacturing androids. Our product lines are fully robotized. The only function which is still formed by human workers is logistics. We're shipping our androids to governments, military companies, etc. We would like to automate this process with an algorithm that will distribute androids depending on their characteristics. Glory to the robots. Oh no. Parallelization is really hitting hard. They can just parallelize these at first. That's 55 up there. Not properly balanced. The upper one needs some more, right? Just for a quick checkup. Oh yeah. That was stupid. Let's do it like this. The upper one will run dry in this. Okay. Let me think about this. We could split this one again. Have this one go into a decision tree. Putting green up here. Red down here. Meaning red and blue, actually. And having this and red here. Oh wait, we need to hit this goal with 27 reds. That's actually not so easy. Maybe we can first parallelize the task. Bit. Ha 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 ha. That one actually is tougher than the ones that came before. Let this one send red all here. This one will send blue here. And greens can go up here. Could probably do some math on this, but way too lazy at the moment. Do we hit the marks? We don't even hit the... Stop. Let's get any other color out here. So this is just blue. This is... Doesn't work. Wow. That went downhill so quick. If red here, else up. And here we could invert it with if green up, else here. If that doesn't work, I'm just gonna hop to the next story mission for the time being. Okay, we're sending way too much up there. Okay. Let's cut it here. Let's go to the next story mission. But we're going to do that in the next episode. Thank you everyone for watching. I hope you enjoyed it as much as I did. I really, really like this game. If you enjoyed what you saw, and if you want to see more, please subscribe to the channel, leave a like. It helps out a ton, and it makes me happy to the fullest. I hope you enjoyed it. See you next time. Bye bye.